So this is a quick video on tutoring problems, working with students when you're working by hand. Calculus 1 is done mostly by computers and with apps now, so you can check your answers automatically. But a student approached me today, first year calculus student, and said, well, my teacher's giving me crazy advanced problems on derivatives and is adding in exponentials and logarithms, and it's very confusing. I said, well, give me an example. So here's the first example. Student said, well, f of x is 7x minus 3 plus ln of x. So how do you do that derivative? And I said, well, just follow your teacher as best you can. Here, what I see is I see a polynomial term, a constant, and I see the natural log of x. So you handle them like elements, one term at a time. Knowing these rules, this is immediately what pops into my head. So according to theory, if the function is a constant, then it's a flat line. So the derivative is 0. It's a horizontal line. If the function is a direct function, ax, then the derivative will just be the slope a. Right? It'll be just the coefficient a. And the derivative of natural log of a function is 1 over the function times the derivative with respect to x. So here we have ln x, so it's going to be 1 over x. So anyway, you do it term by term and you get 7 minus 0 plus 1 over x. That will be the rate of change at any point along the curve. Then the teacher wanted to know, well, what's going on at the moment when x is 1? How is the function changing? What's the steepness of the function as it zigzags along? So when we throw in 1, we throw that into the derivative, and it tells us that the rate of change is 8 units at that moment. So it's a positive steep slope, so it's changing like this, going up, 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 8 units. And the correct answer is E. So then the student said, well, also he's giving us these shortcut rules, like the product rule and the quotient rule. So can you make up a couple of examples that are easier, that don't have trig functions, using the product rule? And I said, well, you know, I was BC Calculus at Bronx Science, and I said, we had to sing songs in class when we learned these rules. He's like, I can't even read this notation. I said, well, read this one on the bottom. And we have, we read it similar to this. I remember we had to chant this in class. She said, product rule. First times derivative of the second plus the second times derivative of the first. So we'd memorize it that way. So you would say it again, product rule. The first times the derivative of the second plus the second times the derivative of the first. So again, we'd say this 5 times in class, and the teacher would stop. Then if you didn't get it in class, on the way on the bus or the train ride home, you'd chant it, and you learn it at night. You'd chant it 5 or 10 times until it was memorized. And that's how we learned all these calculus rules. So he said, well, give me an example. I said, well, polynomials is probably easiest, and I won't give you large ones. So I started with the parabola. I said, how about x squared plus 1 for f of x? And for g of x, how about 2x cubed minus 5x plus 7? She's made it up on the spot. So I said, well, one way of solving that without the product rule is we'd have to multiply the 2 polynomials together by hand. Here, it's a 2-term by a 3-term, so we get 6 terms, group-like terms, and we get that the function is equivalent to the polynomial 2x to the 5th minus 3x cubed plus 7x squared minus 5x plus 7. Well, what do we do now? Well, we know that according to the power rule, just do it term by term. Multiply the exponent by the coefficient and bring the power level down by 1. So 5 times 2 is 10, x to the 4th. 3 times 3 is negative 9x squared. 2 times 7 is 14, x to the 1st, negative 5. And the constants become x to the 0, which is 1. So they become 0, excuse me. The x to the 1s become 0, and the constants, they don't change the curvature of the graph. They just lift it up 7 units, so they don't contribute to the first derivative, if you want to know why constants are 0. All right, so by computing by brute force, by hand, I wrote out with this student, okay, it's this 4-term polynomial. Well, the product rule is just another way of getting to the same answer. So let's put that correct answer up above. It's that quartic up above. But here, what we'll do is we'll color code it. We'll color code f of x. Then as pre-work, you compute the first derivative of x squared is 2x. The derivative of 1 is 0 because it's a constant. It doesn't change the curvature of the graph. G of x is 6x squared minus 5 is its derivative. So now we have the four elements that we're going to lock in place with the product rule, which was first times derivative of the second plus second times derivative of the first. So then by multiplying these two binomials together, we get this trinomial. By multiplying this trinomial by 2x, it's scaled up to a quartic as well. Then by simplifying terms, 6x to the fourth plus 4x to the fourth is 10x to the fourth. Negative 5x squared plus 6x squared is 1x squared, minus 10 is negative 9x squared. Let's see, there's 14x is only here in the second set, and negative 5 is here. So in degree order, it's a perfect match. The student was impressed, said, hey, that kind of really does work out. I said, yes, but in terms of use when you're a first-year calculus student and you have to do it by hand with no apps, with no computers, this method will check your work. It gives you another way of reaching the solution, and you can check and make sure that if you actually do it with the polynomial power rule term by term, we did in the last slide, that you have the exact same final first derivative. So it's a way of checking yourself and knowing that both methods you got the same answer in the correct. There's a high probability that you did it correctly. All right. So that was it for the product rule. Student then said, okay, well, that makes sense. And with polynomials, I see the teachers, just instead of polynomials in place, we have to know these special derivatives for the trig functions, for the natural log, for sine x, for cosine x, and tangent x, et cetera, et cetera. So now the quotient rule is a function divided by a function. Well, here's where you can get a little clever as a teacher. And look at how complicated this function looks. But again, we had a mantra from Bronx Science. And here they said the quotient of the denominator times the derivative of the numerator minus numerator times derivative of the denominator, all divided by the denominator, square of the denominator. Well, that's so clumsy because numerator and denominator, denominator, are 4 and 5 syllable words. So I said, you know, we had a mantra at Bronx Science, and it was bottom times derivative of the top minus top times derivative of the bottom over the bottom squared. Say it again. Bottom times derivative of the top minus top times derivative of the bottom over bottom squared. However, when I went back to Bronx Science to do mock tests and met other students in gifted schools, they said, yeah, the teacher made us say it like a mantra also in class, but we would say bot d top minus top d bot over bot squared. And I thought, hey, that's cool. That kind of makes sense. Just say bot, like robot, like bot. But then you chant that 5 times, you really can also learn the quotient rule. One more time. Bot d top minus top d bot over bot squared. So again, it's a lot less clumsy, and it's almost like a song. And by chanting it 5 times, also if you're taking a bus or subway home, you got it. You got the quotient. So he said, well, can you make up an example using the quotient rule? So being clever and writing lessons for about 10 years now, I thought, well, yeah, I can be clever here. What I'll do is I'll do 2 binomials. I'll scale this one to make it a square times a linear. And this is what came into my head. I said, what about like 5x plus 1 times 2x plus 3? But then I'm going to divide it by the same factor. All right. So what I did was I sketched, and he said, come on, hurry up. We only have an hour. And I said, well, no. Let's do this right. So I wrote it down, and then I wrote it out into 4 terms. Here it is, 10x cubed plus 15x plus 2x plus 3. But then I'm dividing it by 2x plus 3. So it's really hard to factor this unless you do some type of, unless you know the rational roots theorem, and you can do like polynomial long division or synthetic division. But the idea here is that I'm setting up the quotient f of x over g of x. So these terms will cancel. The 2x plus 3 is in the numerator and the denominator. So you can just cross them off the page. Like if I had a pen, just cross off 2x plus 3 on top and bottom. Okay, done. Then the function is just 5x squared plus 1. And by the power rule for derivatives, we get the derivative of 5x squared plus 1 is 10x plus 0, or just 10x. So before we even go into this problem, I know with this student that it's 10x. But again, we have a timed tutoring session, and we're not using any math app to solve it. We're doing it by hand with pencil and paper. So I said, well, let's get to work. So we jump into the quotient rule problem, and I say, well, what's our pre-work? Well, we have to take the functions f of x and g of x. All right, I just wrote this problem. And then we have to do the derivative of f of x and g of x, and then follow the mantra, bottom d top minus top d bot over bot squared. So I said, well, here's the function. The first derivative is 10x squared plus 30x plus 2. The student goes, yeah, okay. And then this one is 2x plus 3, so it's the derivative. He's like, oh, it's just 2. Yeah, okay. So we lock the pieces in place like a puzzle. Then you have to do 2x plus 3 times the trinomial minus 2 times the function from the top, divided by the bottom squared. And by expanding out, following the rules, we got 60x squared plus 90x over 2x squared plus 3 times 3. I said, well, what can you do now? He goes, well, I don't know. Can't you just, don't you want to do the bottom is 4x squared plus 12x plus 9? I said, no. Left factor the top. Tell me what you get. He said, it's 30x times 2x plus 3. I said, aha. See how the factor cancels? And we get that the correct derivative is 30x over 2x plus 3. But that's wrong, because I already did the derivative before, and I know it has to be 10x. I know it's 10x, going back to this slide, because I know that this is supposed to cancel all the terms here and just be 10x. So the student said, well, that's pretty cool, because a lot of that stuff canceled, and it's just 30x over 2x plus 3, right? And I said, no, but that's the method. That's the way we plug in, and that's how we do it. I said, oh, great. All right. So he goes, okay, well, I have to go on. I have 2 other APs to study for. So I'm sitting there as we log off, and I'm like, this is not fair to this student, because you want it to be perfect. But he didn't tell me that we were going to do quotient and product rules tonight. And I have a few worksheets, but he said, make one up on the spot. And I did what he told me to do. I made up a problem. But look, there's a problem with the numbers here somewhere. So I logged off. I sat there for 15, 20 minutes, couldn't find the error. Finally found it, wrote it out twice, 3 times. First derivative is wrong. So there's an error on the page. The first derivative, I told you, it's the exponent times the coefficient. 3 times 10 is 30x squared. 2 times 5 is 15x plus 2. So I'd written down the wrong first derivative. So that's why the math didn't work out. That's why we had this weird answer, even though miraculously somehow it was factorable and 2x plus 3 canceled. So I'm offline. Kid's already done for the night. He's got 2 other APs to study for. So he's totally stressed, doing college level work. I went back, plugged it in, wrote it out with 30x squared properly, and noticed that a whole bunch of terms come up. But when you cancel it, you get 40x cubed plus 120x squared plus 90x. Left factor the 10x. And lo and behold, if you expand the trinomial on the bottom, which is probably in some textbook if you were the college teacher and had set it up. But again, like I said, this I just made up on the spot. So that trinomial cancels that trinomial, and the answer is 10x done. So I'm making this video tonight just to say that, when you're in a time crunch and you're making stuff on the spot, I really feel like an obsolete teacher, even when I'm teaching calculus, because the way the apps are, the way the support is, you just press a button and they'll break it down step by step, like, and you'll be able to see a correct solution because it's done instantaneously now, because all of these rules are programmed into computer algorithms, especially for calculus levels 1, 2, and 3. Even me, I did 3 years of calculus, and what I know by heart is just done with the touch of a button. So I just thought I'd share this video on what's interesting about still being a calculus teacher and tutor. And even if I make up a question that I consider simple, but the point was to show how if you factor cancel, it's even easier than the quotient rule when doing it in practice. But these are that's how I write my worksheet, so that students can have examples that are college level that deepen their understanding of the uses and natures of these rules in calculus as they learn more about the system. So thanks for watching my video. I hope it was interesting to you and entertaining. Just being a tutor, a private tutor, and enjoy your studies of calculus. I hope you're able to achieve the mastery of the lessons that you're working on, and have a good night.